Right, guys, welcome to the solutions video. We're using this assignment to figure out how ready you are for the final, which is going to cover a bunch of triangle stuff. What kind of triangle stuff? Well, slide 2 here has your triangle toolkit. These are the important formulas to keep in mind. In the top left here, we've got sine, cosine, and tangent. We use that to solve for sides and triangles when you know an angle and another side. It has to be a right triangle. If it's not a right triangle, you might try out this formula up here, the law of sines, which works with any triangle, not just right triangles. If you know two sides and you're trying to find another one, you might do the Pythagorean theorem, a squared plus b squared equals c squared. If you know two of those sides, you can fill them in and get the other one. If you're trying to find an angle using side lengths, you would use inverse trig, inverse sine, cosine, and tangent. And then also, if it's not a right triangle, you might try out the law of cosines, which we have down here at the bottom. And again, that's if it's not a right triangle. Let's jump in and do some of these problems. On slide 3, we've got our first one up. Notice it is a right triangle. That should narrow down which formula to use. Then think about, are you trying to find an angle or are you trying to find a side? Looks like we're trying to find a side. If we were trying to find an angle, we do inverse sine, cosine, and tangent. But we're trying to find a side here. Now, if we knew two sides and we're trying to find the other one, we'd do the Pythagorean theorem. But since we know an angle and a side, that's our key that we're doing sine, cosine, and tangent. The question is, which one? Is it sine or cosine or tangent? To determine that, you have to label your sides to know which sides we're using here. Opposite, adjacent, and hypotenuse. Which two are we using? Well, across from the 90-degree angle is the side that we'll always call the hypotenuse. And then we need to pick which angle are we going to reference from here. Probably makes sense to choose the one that we already know to avoid the extra work of figuring out the missing one. The side across from that is what we call the opposite side. If you have trouble figuring those out, remember the two sides that create the angle are the sides that are not the opposite side, okay? And you can do the same thing for finding the hypotenuse. The two sides that create the 90 are not the hypotenuse, so that's the way to get that opposite side if you have trouble with that. Anyway, we now know that we're looking for the hypotenuse and we know the opposite side. So we need to look back at our formulas, or unless you have them memorized, and notice that sine uses opposite and hypotenuse. So this is going to be sine. It's not going to be cosine because that's adjacent and hypotenuse. It's not going to be tangent because that's opposite and adjacent. That's why this is sine, because it's opposite and hypotenuse. So now we're going to fill that formula in using the values in our problem. So it's sine, and then the angle that we referenced from was 60 degrees, and then that would be equal to a fraction with the opposite on top, that's the 5, and the hypotenuse on the bottom, that's the x. We just need to solve this equation now. There's more than one right way to do that, but one method that a lot of people like is cross multiplication. You can always put a 1 on the bottom of something. That doesn't change its value. Now we have two equal fractions, and a lot of people like to solve problems like that using cross multiplication. That's where we do that. 1 times 5 is 5, and that would be equal to x times sine 60, which is just x times sine 60. Well, we want to get x by itself. Sine 60 is just a number. Our calculator knows what it is. So we could just divide by it. If you had 2x, you would divide by 2, right? If we have sine 60 times x, we just divide by sine 60. And that's going to leave us with x by itself is equal to whatever 5 divided by sine 60 is. That's your exact answer, but usually we'd want a rounded one. We'll pop out a calculator, and we're going to do 5 divided by sine 60. And that comes out as about 5.7735. We didn't say how far to round this, so I'm just gonna pick that much. Okay. All right, there we go. Let's move on to number 4. On number 4, once again we're solving for x. X is a side length. It's a right triangle, so we don't need to think about law of sines or law of cosines, but we need to think through our right triangle problems. It's not inverse trig because we're not finding an angle. But is this going to be sine, cosine, and tangent? Well, don't we need to know angles if we're going to do that? In this case, we know two sides in a right triangle, and we're trying to find the other one. We have a formula designed specifically for that. The best tool for the job here is going to be the Pythagorean theorem. The key to this formula is that A and B are the two sides that create the 90. Those are your legs. And then C is the side across from the 90. That's your hypotenuse. And you got to get those in the correct spots in the formula. Let's jump over to this problem. In this case, across from the 90 is the 14. That's your hypotenuse. So in this formula, we call that C. And then the two that create the 90 are going to be your A and B. So let's fill it in. We've got a squared plus b squared equals c squared. Well, that's x squared plus 10 squared equals c squared. So how do we solve this? C squared. We know what c is. Sorry, guys. We know what c is. C is 14, isn't it? So that would be 14 squared. Okay, so how do we actually solve this? Well, let's simplify. What is 10 squared? 10 squared is 100. What is 14 squared? Well, that's 14 times 14. I think that's 196, but since I'm making a video, I'm going to actually be sure. 14 times 14 is 196, yes. Okay, so we've got x squared plus 100 is equal to 196. We're solving an equation. We want to get x squared by itself, so let's use subtraction. Let's subtract the 100 away from the x squared, and to keep things equal, we're going to have to do that to both sides of the equation. What are we left with? X squared plus 100 minus 100 is just x squared. 196 minus 100 is just 96. Right, we're left with x squared is equal to 96. What do we do with that? Well, we want to figure out what x is, not what x squared is. So one way to think about that is the inverse operation of squaring is square rooting. That's how you undo it. So that's going to leave you with x is equal to the square root of 96, which we could round on a calculator. Square root of 96 comes out as about 9.797959, blah, blah, blah. I'm just going to be lazy and round it to 9.8. Why would it not be 9.7? Well, the number after the 7 is a 9. That's 5 or bigger, so when we round it, we round that up. I'm going to make this a squiggly for approximately equals. The exact answer is just the square root of 96. All right, let's move along here. All right, for this one, we've got a side length missing. It's a right triangle. So, and this time we know an angle. So is this going to be the Pythagorean theorem again? No, because this time we don't know two sides. We just know one side. But we do know an angle. This is going to be a lot like the problem we did in here. It's the same type of information. So we're going to use the same type of process. We want to know, is it sine, is it cosine, or is it tangent? To do that, we have to know which side is which. So let's label our sides. Let's use this as our reference angle since that's the one that we know. X is opposite from there. The 20 is across from the 90. So that's going to be our hypotenuse. And that would leave the adjacent to be down here, but we're actually just using the hypotenuse and the opposite in this problem. So again, check our formulas. Opposite and hypotenuse, this one is sine again. Again, cosine doesn't use opposite and hypotenuse, neither does tangent. That's why this is a sine problem. So let's fill in our sine formula. We've got sine of 15 is equal to the opposite, which is x, over the hypotenuse, which is 20. Again, one way to do this is cross multiply. You can put a 1 on the bottom and multiply. 1 times x is x is equal to 20 times sine 15, which we can do on our calculator. 20 times sine 15 comes out as about 5.17638, blah, blah, blah. I'm going to call that about 5.18. Again, the 7 rounds up to an 8 because the number after it is bigger than 5. 5 or bigger. All right, let's move along here. We're on to slide 6. Okay. First thing to notice, is it a right triangle? It's not. If you're not sure, you could find this missing one by doing 180 minus these other two, and you can tell it's not 90. So this is not a right triangle. So we can't use some of our formulas. In a right triangle, in a non-right triangle, all we have to consider are the law of sines or the law of cosines. Those are the only ones that we can consider. So what are we going to use, law of sines or law of cosines? Well, let's look at the kind of information we have. In this case, we have an angle and the side across from it, as well as another angle and the side across from it. That is going to be a law of sines problem. Notice the law of sines is sine of an angle divided by the side across from it equals the sine of another angle divided by the side across from it. The law of cosines, on the other hand, only uses one angle. So that's why this is going to be a law of sines problem. Okay, sine of an angle, side across from it makes a fraction. Do that twice. Let's do it. Okay, so sine 26, side across from it is 4. Oh, well, let's see. I guess I'll do it in red. Since I'm in red here, I'll do the sine 42. Side across from it is x. And again, the other one will be sine 26. And the side across from it is 4. All right, from here, we are going to cross multiply. X times sine 26. What's that? Times. Erase that. X times sine 26 is equal to the other diagonal multiply together. 4 times sine 42. Well, we can pop out a calculator and do that. 4 times sine 42. That gives us 2.676, blah, 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 blah. Let's call that 2.6765. All right, from here we want to get x by itself. It's being multiplied by something. It's being multiplied by sine 26. Let's divide by that. Sine 26, sine 26. And that leaves us with x is equal to 2.6765 divided by sine 26. Let's do that on a calculator. By the way, to get even more accurate, instead of rounding this, I'm going to copy all of that. And then I'm going to paste it, and I'm going to do divided by sine 26. That's going to get me more decimals of accuracy than if I had rounded it more. So that's going to leave us with 6.1056, blah, blah, blah. I'm going to call that 6.11. The 0 rounds up to a 1 because the number after it is a 5. All right, let's move along. So number 7. It's a right triangle, so it's not law of sines or law of cosines. We know 2 of the sides, so if we wanted to find the third side, this would be a Pythagorean theorem problem. A squared plus b squared equals c squared. But that's not the case. We're trying to find an angle. So we have one particular type of formula that's good for finding angles when we know sides in right triangles. Let's hop back to our triangle toolkit. It's the inverse trig. Sine inverse, cosine inverse, tangent inverse. We use these to find angles using sides. So we need to know, relative to our angle, are we dealing with the opposite and hypotenuse, adjacent and hypotenuse, or opposite and adjacent? That'll tell us which one to use. So let's hop back to our problem. Here we go. From the x, across from it is our opposite side. Remember, that's the side that is not one of the two that create the angle. Here's our 90-degree angle. The side that is not one of the two that create it, the one that is across from it, is the hypotenuse, and the one that's left over is the adjacent side. That means the side next to the angle that's not the hypotenuse. That means we're using the adjacent side and the opposite side in this problem. So we're looking back at our formulas. Which one is opposite and adjacent? Well, it's not sine, it's not cosine, it is tangent, opposite and adjacent. So this will be tangent inverse. And we'll type it in as tangent inverse, type in both numbers in the correct order in the fraction, and we'll put that in the calculator, and it's going to give us equals the angle. So that's it. Don't even need to solve an equation. So we're going to do tangent inverse of the fraction opposite 5 over adjacent 8. Put that in the calculator and see what we get. So we're going to go function to open up the function menu. That'll have the tangent inverse in it. And then back to the main menu to type our numbers, 5 divided by 8. And that comes in as about 32.0 degrees. There we go. All right, number 8. Hey, once again, it's a right triangle. Once again, we are trying to find an angle, not a side length. So once again, this will be inverse sine, cosine, or tangent. How are we going to do it? Well, again, this angle is created by 2 lines. The other one, opposite from that, is our opposite side. Our 90 is created by 2 lines. The other one, across from that, is the hypotenuse. And that's the two we're using here, opposite and hypotenuse. So if you haven't memorized it yet, you hop on back to your notes. And you look here. Sine is opposite and hypotenuse. So this will be sine. Cosine is adjacent to hypotenuse, so it's not that. Tangent is opposite and adjacent, so it's not that. Opposite and hypotenuse is only sine. So this will be sine inverse. Type in your fraction, and it'll give us the angle. All right, so like we said, sine is, it'll be sine inverse because we're typing in the ratio to get the angle. Opposite on top, 4. Hypotenuse on the bottom, that is 5. And open up our calculator. Go to the function menu to get our inverse sine. Then we'll type in 4 over 5. Back to the main menu to get those numbers available. We got 53.13 degrees. There we go. Moving on, we're almost done, guys. Slide 9, we got this problem. It's a right triangle again. So it's not going to be law of sines or law of cosines, unless we really wanted it to be. Let's see, we know an angle and we know a side. We're trying to find another side. We're trying to find a side, so it's not going to be inverse. And it's not going to be Pythagorean theorem because we don't know two sides. So that means it's going to be normal sine, cosine, or tangent, which means we need to figure out, is it like which side is which? So if we're going to use this angle, which would be the convenient one to use, this would be our opposite side. Across from the 90 would be our hypotenuse, which means that this side would be our adjacent side, and we know the opposite side, we're trying to find the adjacent side. So this is opposite and adjacent. If you haven't memorized it yet, you could check your notes. Tangent is opposite and adjacent. So this is going to be a tangent problem. So tangent of the angle equals the fraction. Remember, not doing inverse this time because we're not finding angles. All right, so we're going to do tangent of the angle 15 is equal to the fraction with opposite on top, that's 5, adjacent on the bottom, that's x. I'm going to put a 1 on the bottom and cross multiply. 1 times 5 is 5, and that would be equal to x times tangent 15, which we could just write down as x times tangent 15. Tangent 15 is just a number. If it was 2, you would have 2x equals 5, and you'd just divide by 2, right? In this case, tangent 15 is just a number. Just divide by it to get x by itself, right? So we're going to divide both sides here by tangent 15. And that leaves you with x equals whatever 5 divided by tangent 15 is. Well, let's type that in our calculator. 5 divided by tangent 15 comes out as about 18.66. And that's approximately equals. And we're moving on. All right, number 10. Number 10, it's a right triangle. We're not trying to find an angle, we're trying to find a side, but we don't know any of the other angles. We know 2 of the sides, though. So this is going to be the Pythagorean theorem. Reminder what that is, if you check your notes, that's where we have a squared plus b squared equals c squared, and a and b are the 2 legs, the 2 sides that make the 90. C is the hypotenuse, the one across from the 90, that's not one of the 2 that make the 90. That's what we use when we know 2 sides in a right triangle, and we're trying to find the other one. So let's this one. Here we go. So which ones are our A's and our B's? Well, our 90 is formed by 2 lines. That's your A and your B. Those are your legs. Across from the 90 is C. That's the hypotenuse. So A squared, that's going to be x squared, plus B squared, that's going to be 12 squared, equals C squared. That's going to be 15 squared. Just like last time, we're going to simplify. 12 times 12 is what 12 squared means. We have x squared plus whatever 12 times 12 is. I know that that's 144, right? But I'm making a video, so I'm paranoid about getting answers wrong on video. So we're going to do it on here to be sure. 12 times 12 is 144. And that is equal to 15 times 15. That's what square means, right? Times itself. So 15 times 15 is 225. All right, we want to get x squared by itself, which means we probably don't want that plus 144, so we'll do the inverse operation, the opposite of that. Subtract 144. Do it to both sides of the equation so that they remain equal, and that's going to leave us with x squared is equal to whatever 225 minus 144 is. 225 minus 144 is 81. So we have x squared is equal to 81. From here, we want to get x by itself. We don't want it to be squared, so we're going to have to do something. How about we square root to make x just be x. That's going to give us whatever the square root of 81 is, which is actually 9, exactly 9. So I didn't need these squigglies. It is exactly 9. All right, let's move along. Number 11. Is it a right triangle? Well, let's check. The angles in triangle add up to 180. We know that one of them is 55. Let's subtract that. One of them is 35. Let's subtract that. That actually leaves us with 90, which means this is actually a right triangle. Which means we can use normal, sine, cosine, or tangent here. But let's say that you didn't really notice this is a right triangle. Let's say that you figured out that this was 90 degrees, but you kind of forgot that this was a right triangle since it seemed different. Could you have used the law of sines here? You could have. So I'm going to demonstrate the law of sines here again. Remember, that's the sine of an angle divided by its opposite side is equal to the sine of an angle divided by its opposite side. Now remember, I'm not saying this is the most efficient way to do this problem. I've just noticed that sometimes students kind of think about that when they weren't given an obvious 90-degree angle. So you could do the problem this way. However, I want to remind you that if we do figure out that that's a 90, you could just do normal sine, cosine, or tangent. But that might confuse you because we know two of the angles. Literally just pick either one. If you pick the 55, this will be your opposite side. If you'd picked the 35, this would have been your opposite side. You just need to pick one. It's not going to matter which one you do. You just need to pick one. I'm going to do it from the 55. So from the 55, that's our opposite side. This is going to be the hypotenuse either way because the 90 doesn't change. This would be the adjacent side, again, if you're using the 55. This is going to be opposite. This is going to be hypotenuse. And if you check your notes, that's going to be sine. Now, to be clear, it's okay if you use the 35 here. You would just have things flipped around. You'd be using cosine instead from the 35, but your equation will end up getting you the same answer. Anyway, we have sine of 55 is equal to the opposite side, which is 17, over the hypotenuse, which is x. From here, you could put a 1 on the bottom and cross multiply. 1 times 17 is 17, and that would be equal to x times sine 55. From here, you want to get x by itself, so you could divide both sides by sine 55. And that gives us x is equal to whatever 17 divided by sine 55 is. Let's type that in the calculator. This would be 20.75-ish, approximately equals. All right, guys, that's the end. Last thing here is based on this review, how ready do you feel for the final? Which types of problems should you study more? When do you plan to study? Who will you work with or get help from? Good things to think about. Hope this video was useful for you, and I hope you have an excellent day.